So, welcome back. Today, I'd like to do a real quick video on feedback mechanisms, specifically feedback loops. Right? And so, feedback mechanisms, feedback loops are a very general thing. They're not biology specific. Okay? It's just when you have a stimulus and a reaction and how that reaction relates back to that initial stimulus. And so in biology, we utilize feedback as part of our cellular communication storyline, as part of our homeostatic storyline. Just it's the way that our body can regulate how it responds to certain stimuli and certain conditions. So there are two types of feedback loops. There are positive feedback loops and there are negative feedback loops. And so a positive feedback loop is when the stimulus triggers a response that results in more of the stimulus. And so this is easy to think of in terms of professional sports or just, amateur sports at that. Sports in general, right? And so if you imagine a player being on a hot streak, right? Let's say it's basketball. Okay? And so the player takes a nice three-point shot, buckets, right? All net, swish, feeling good. Right? And so then he goes play some defense, gets the ball back, comes back down court. He's like, I just hit that shot last time. I'm going to take another one. And boom, feeling confident, feeling free and relaxed, hits another shot. Right? Builds up more confidence. And the more shots he hits, the more confident he's going to feel, the more shots he's going to hit. Right? And so this hot streak is an example of a positive feedback loop. Now the inverse is also true. Right? He goes down court, takes that first shot, bricks it, right? Off the rim, comes back like, that was terrible. Right? So he goes back down, plays some defense, get the ball again, comes back, he's on that three-point line again. He's feeling a little bit tentative because he knows he just missed. And so he puts it up, air ball. His soul is crushed, right? He's like, I don't even really want to shoot again. So he avoids shooting for a little bit, right? Whole quarter goes by, hasn't shot again. Gets the ball, knows he has to take the shot, but he's feeling really nervous. He's like, and he throws it up and bricks it again, right? And so this is also an example of a positive feedback loop. Even though the result was negative, right? Even though it was a sad result, it's still a positive feedback loop. The stimulus triggered a response that increased more of the stimulus, right? The more that he missed, the more that he was going to miss even more. Okay? Those are positive feedback loops. Negative feedback loops are when the stimulus triggers a response that stops the stimulus. Okay? And so if I hear the baby crying, right, my response is to go to the baby and give the baby some food. And now the baby stopped crying, right? That was a negative feedback loop. Okay? Response gets rid of the stimulus. Now, in biological functions, in cell communication and cell regulation, a great number of our feedback loops are going to be negative. Right? And that innately makes sense because most of our responses to change are to try to stop that change. Right? Our body is already at a homeostatically happy place. Right? I don't want it to change. I want it to stay the same. So whatever response my body does in response to the stimulus is to cancel out the effects of that stimulus. Right? And so if I get too hot, my body's response is to cool down. I'm stopping that stimulus. If the pH of my blood rises, my body's response is to try to bring it back down. I try to cancel out that stimulus. And so in most conditions, we are trying to maintain homeostasis through negative feedback loops. Okay, so most examples are going to be negative feedback loops. There are a few circumstances in our biological functions where positive feedback loops are good. One example is blood clotting. Right? So when you get a cut, our blood is exposed to the air. That triggers the chemical that leads to clotting. So those blood cells start clotting up. Right? The clot itself triggers the same reaction. Okay? And so the stimulus triggers the response, which triggers more of the stimulus. Right? So I build up this clot. Eventually, I want the clotting to stop. And so it's going to reach a point where it's like, all right, that's cool. Right? But it builds on itself. Labor. For women giving birth, is a positive feedback loop, right? The baby head pushes on the cervix, right? Releases a certain set of hormones. Those hormones trigger reactions that lead to contractions of the uterus, push the baby down further. More pressure, more hormones, more contractions, more pressure, more hormones, more contractions until the baby slides out. Right? I don't know if slides out is the appropriately determined adjective, but that's what we're going to pretend just slides out. Okay? Those are positive feedback loops. So yeah, that's literally it. Real short video. Bye.